All right, guys. I've been waiting for other folks to join in. Looks like that's the number of folks we have right now. Let's start with the session. I've waited for enough time. Okay. Before that, just quickly give me yes in the chat if everybody can hear me loud and clear and see the sublime text. Quickly give me yes in the chat if everybody can hear me loud and clear and they can see the sublime text. All of you. Come on, guys, quick in the chat. All of you guys can. Cool. All right. This is the first class that we are going to have for low-level design. But before I move forward, I can see very less number of people have joined. I don't know what's the exact reason, whether that was not communicated or something like that. So I just waited for all of you to join, but looks like not many people are joining. So either they are not informed or something like that. Anyways, before I move forward, let's quickly start with what are we going to discuss as part of this low-level design course. Set the agenda. But before I move there, this is the very first class of low-level design. In this low-level design, we'll talk about multiple things. I'll write down the agenda again, but just to tell you over a view level, this is what we'll be discussing as part of this low-level design. There's going to be roughly 10 to 12 classes in total for low-level design. We'll start from requirement gathering, understanding the laying down the use case. We'll talk about the UML and class diagrams and type and purpose of the same, which includes class diagram, activity diagram, use case diagram, and sequence diagram. Then we'll talk about object-oriented programming versus object-oriented design. We'll try to understand difference between classes and objects. What is NVT technique here? We talked about the case study, and then we'll make the diagram using draw.io. Okay. Then we'll move on to the different class relations, assigning the responsibility to classes. The relation between classes includes composition, aggregation, inheritance. Okay. Then we'll talk about abstraction versus encapsulation. We'll learn how to convert the object-oriented design to model problem, and finally how to implement the code, which includes design pattern, solid, keep it simple and short, dry, and some of the best practices. Okay. Then we'll go for the case studies. Yeah, that is also case studies is also there. Let me create space here. And last part is case studies. We'll have 3 case studies as part of this batch. All right, now let me write down the agenda that I've been talking about. I believe all of you have been taught by me before. If there is anybody who has not been taught by me before, let me know in any of the batch. Anybody's there? One moment. Yeah, we'll be covering concurrence and everything. Is anybody there who has not been taught by me before in any of the batches? Nope. All of you have been taught by me. Cool. That will say my introduction, so we can directly move on to the agenda. So this is the agenda that we're going to cover as part of this batch. As I said, it will take roughly 10 to 12 classes, depending upon how speed that we got. We'll start with basics of LLD. One moment. We'll start with basics of LLD. Then we'll talk about solid design, solid principles. Then we'll talk about design patterns. And then we'll talk about the case study. Okay, this is the sequence flow. Yeah, we can take consistent hashing. Usually I try to cover like this, 2 classes. In the first 2 classes, I cover everything related to the basics of LLD. Okay. Some of you have already covered the high level design. Some of you have not covered it. So don't worry about it. Those who have covered it high level design, you guys are covering low level design now. Your system design will be complete. Those who are covering low level design first, after this, you will cover the high level design. So your system design will be completed then. So there are multiple batches which are going in parallel. So basics of LLD, which includes my object-oriented design, object-oriented programming, NVT technique, UML diagrams, which includes class, activity, etc. etc. Okay, that is what I usually cover in the first 2 classes, understanding the very clarity of basics of low-level design. Once you have basics clear, then I take 3 classes for completing the solid principle. Solid principle is a very important concept, so it takes 3 classes. When I say 3 classes, we are also going to take a code example with each one of them. That's why it takes so much time. It's not just the theory part of it. Then the next 3 classes, I focus more on the design patterns. Your question, there is no requirement to know all the design pattern. There are 23 design patterns in total, 22, 23. And you don't need to know all 23 design patterns. Out of that, majority of the, I would say 90% of the problems in software engineering, they can be solved with the 8 or 9 design patterns. So the most important design pattern, that is what we'll follow about here. Okay. Fourth, the last 3 classes, I would keep for case studies. This is how your entire agenda for low level design will look like. Okay. So first we complete basics of LLD, then we go for the solid principles, then we cover the design pattern and finally move to the case studies, which is implementation. So these are all theory part of it. Along with theory, we'll write them code as well. This is completely purely code. Whatever we have learned so far, we'll implement that in the code part. Okay. All right, guys, that's what the agenda of your low-level design course will look like. Now, let me clarify the first difference. Since we're in low-level design course, let me clarify the very first difference is by mid-Feb, the LLD would be completed, right? Depends how's the pace that we go for. Usually these classes are for 2.5 hours. So the previous batch is for 2.5 hours. That's what I'm referring a reference for. But considering we have 2 hour batches, it might be further extended. Okay. So 10 to 12 classes, this is 2.5 hour classes. So you can furtherly take care for the 2 hour class, how much it will be adjusted. So you can assume like 15 to 16. But on overview level, even if you're taking a 2 hour class, 2 months is something which will take you to complete it. Okay. All right. Now coming to high level design part. The first thing I want to clarify is understand the difference between high level design versus low level design. Okay. So you should know exactly what is that you have learned or about to learn in a high level design and what is that you're going to learn for the low level design. Okay. High level design versus low level design. System design has two parts. One is called the high level design, other is called the low level design. It's very clear by the name itself. On high level design, we talked about the components. We don't go into the details of the code. We don't talk about how it is implemented. We just talked about how the components are interacting with each other. Low level design, on the other hand, goes to the implementation. We talk about the code, we talked about the design principles, we talked about the best practices, and we talked about how the code is written and what quality it is written. Okay. So let's take an example of high level design. I'll give you all of them with an example. Let's say in a high level design, I'm asked to design WhatsApp. This is what my problem statement is. If I'm asked to design WhatsApp, so what will be the focus? The focus here will be I'll focus a top-down approach. What do you mean by top-down approach? Top-down approach means you'll talk all the components on the higher level. So I'll talk about client server. You'll talk about load balancing. You'll talk about load balancing, CDN, etc. I'm covering all of them here. What are the various components in the system? We'll talk about services, which includes group service, user profile, chat service, messaging service, whatever you want to call it. Okay. Then you will talk about DB schema. So DB schema includes which kind of database, what kind of tables, what kind of data to store, where to store, how to flow the data, etc. Number 5, data flow. Number 6, caching. Number 7, analytics. Number 8, security and other aspects. Okay, all of these things you will talk about in a high level design. So what exactly you are doing in the case of a high level design? High level design means you are given a particular product or a particular service that you have to design. What should be the format in which it should be designed? What should be the request? What should be the response? What should be the client? How does it goes to server? What are all the paths that we have to go through in terms of storing the data, getting the responses, putting the request? Everything will be taken care by the high level design. Again, we don't talk about code. We don't talk about best practices. We just talk on the higher level. What should be the components made? Okay. When we say low level design, low level design means what exactly? Let's talk about low level design. Low level design means we'll start with number 1, requirement gathering. Number 2, laying down the use cases. Laying down the use cases. Number 3, whatever our UML diagram or class diagram, what are the different kind of diagram, what are its purposes, so on and so forth. Number 4, object-oriented design to model the real world problem. And finally, we move to implement code. In terms of implementing code, we'll talk about design patterns, we'll talk about solid principles, and finally, all other things. Keep it simple and short, other patterns, etc. etc. That is what we finally use in machine coding now. Okay, this is what your low-level design looks like. So in a low-level design, you'll start with understanding the requirement gathering, laying down the use case. You'll make some kind of UML diagrams, different kind of UML diagrams. How do you convert object-oriented design to model the real-world problem? And finally, how do you actually write down the code? So there will be machine coding round, which we'll discuss in the case studies. That is what low-level design looks like. Everybody crystal clear with what is in the scope of high-level design and what is in the scope of low-level design. Anybody has any doubts, any questions, please let me know. It's very important to know what is the scope that we're going to cover as part of HLD and what is the scope that we're going to cover as part of LLD. Any doubts? Anything which is not clear? Okay. If everything is clear, then I can move to next part. So once we know the clarification between HLD and LLD, this is our LLD course. First thing that I want to share is some good resources. Okay. I can recommend some resources that will be very helpful to boost. LLD will not talk about component. No, we'll not talk about. We'll talk about diagram, like component diagram. No, we'll not talk about cache seed and all of that. We will not talk about all of that. Okay. We'll talk about specifically different kind of diagrams, which are UML diagrams, and we'll talk about how do you implement the code. That's what is called low level design. Now coming to it, apart from this course, I mean, this course is sufficient enough to take you to the interview or to clear the interviews, but I would highly recommend don't limit your knowledge on HLD or LLD in general based upon a particular course itself. I highly recommend go above and beyond, read more books, and there are some very good books available in the market. That's what I'm going to give reference. Yes, microservices will be covered. So in terms of resources, I'm giving you three resources. If you cover these three resources, that should be more than sufficient. Again, this course itself, whichever it goes for 10 to 12 classes or whatever number of classes, that is sufficient enough for you to understand what is low level design, clear the interviews on top of it. But engineering is never about clearing the interview. Engineering is all about becoming a better engineer. So I'm mentioning some resources. My recommendation is definitely read it. If you have it, well and good. If you don't have it, you can order it. You can have a Kindle version, whatever you prefer. Okay. The first really good book is Design Patterns. Okay. Elements of reusable object oriented software. Okay. Hardcover. This was published back in October 31st, 1994. Okay. This is a really good book in terms of if you want to understand design pattern. This is the best book. This was written by four C++ engineers and whom we normally call as Gang of Four. Okay, Gang of Four. So this eventually highlights 23 design patterns in total. Okay. Obviously, if you look from 1994 back to 2025, it's almost 30 years, 31 years, right? A lot many new design patterns have come, but at the end of the day, it's not like whatever 22, 23 design patterns they talked about in this book, they have changed significantly. Yes, there are new design patterns. Yes, there have been new changes. And in 30 years, IT industry has changed a lot, no doubt about it. But the kind of design patterns that they have highlighted here, more or less, whatever new design patterns that we have, it is just a variation of these patterns only. Sometimes it's a hybrid. We combine multiple design patterns to make another design pattern. Okay. So this is the first book I would recommend anybody who wants to be an expert in LLD or anybody who wants to know about the design patterns. This is the first book I would like to recommend. There are more books, but if you read this book thoroughly, I don't think you need to know more books. Obviously, there is no limit to knowledge, but this is a very good book if and first recommendation for the resources. Second, again, a very good book is Designing Data Intensive Applications. Okay. This is by Aurelie. This is also a very good book. So this designing data intensive application that talks about how do you write an application which works with a lot of data. Okay, that's what the word data intensive application. So it also includes some of the good principles like what should be the principles for writing the program, where should you use the database, how do you store the values. All of that is covered here. So this is also a very good book, highly recommended. Okay. And last, there is a website. It's not book. The website is refactoring.guru. This is a good website. So if you want to learn more about some design pattern, let's say, or some solid principle, there's some very good articles which are written here. Some of the articles I have written, some of the articles other technical experts have written, but this is a really good website. So if you want to learn about from a website, this would be my recommendation. And these are one and two are the books here. Okay. All right. I've covered the resources. Now let's start with number one, which is understanding what is requirement gathering. Okay. So where we are, can you provide HLD resource also? I think HLD I already provided in the case of one moment. Gango 4 is design patterns, element of result paper, paperback one, January 2015. The original book was from 1995. They may have different versions and all of that, but the original book is from 1995. You can find that on Amazon or Flipkart or anything else like that. Okay. To your question for the HLD resource I have already provided in the case of HLD course. But if you don't have access to that or you are not involved in that, this is something I would recommend for HLD resource. So system design interview, volume 2, that is by Alexu. Okay. You also have a blog called Byte Go. Okay. That's something you can refer to. At least from the very basic level, if you have to understand high level design, this is a very good book. Okay. And then if you grow, if you think you have very clear knowledge of the basics and the intermediate level, and if you want to learn from the expert level, then there's a good website called highavailability.com. Okay. This I recommend for technical architects and lead engineers. And this is for all level. This is mostly like basics and intermediate. And this is like an expert level. Okay. Basic and intermediate. So if you want to read a book, this is one book I'd recommend. If you want to read a website, this is the website I would recommend for high level design. Okay. All right, guys. Now let's move on to the next part. The next part is this is where we are. We talked about the agenda. We talked about the high level design versus low level design. We talked about some of the resources for high level as well as low level design. Now, coming to the very first part, which is requirement gathering. Any part of any design is the first part is requirement gathering. So, what kind of requirement we are talking about in the case of LLD? Okay. So, I'll give a very simple example to understand that requirement gathering. Build low level design for a parking lot system. That's it. This is your problem statement, nothing else. If such kind of problem statement is given to you, and let's say in the interview or let's say in any in general in discussion, such kind of problem statement is given to you. Build a low-level design for a parking lot system. What kind of follow-up question that you should ask? Is this statement sufficient enough to for you to start working on a design? Is this statement enough for you to start working on a design? Yes or no? If it is not, why it is not enough? What is something which is ambiguous about it? What is something which is ambiguous about it? What is something that you need to clarify before you can actually start? Come on, guys, be quick. Let's understand one by one. If somebody gives this problem statement, be low level design for a parking lot system, there are many things which are unknown in this. So I need to ask good clarifying question. That is what you call as requirement gathering. Okay. What can be that? We don't call it functional non-function. That's the term we keep it to high level design. In general, we don't call it functional non-function. There is no non-functional as such here. We just call it as requirement gathering, where we talk about very clarity. The first thing is, and the first most important, when you say parking lot, is it one level parking lot or is it multi-level parking lot? Because my design will change according to that. Number one. Number two, when you say parking lot, what kind of vehicles we are talking about? Are we talking about cars? We're talking about bikes? We're talking about trucks? What are we talking about? So one type of vehicle or multiple type of vehicle? Which kind of vehicle we are talking about? Next, is it one place? Like when we say parking lot, is it only one place or it is spread across the cities? Next, is it one user or multiple users? Etc. etc. You can find many questions like that. So what do you need to do? You need to build low-level design for a parking lot system. The first thing that you have to do is you have to make a very clear requirement gathering. You have to understand what kind of requirements we're talking about. Why? Why we need to know that? Let me give you an example. Let's take this example. Why do I need this piece of information? I need this piece of information because when I move to write to the code and I don't have the proper information whether I'm going to have one type of vehicle or multiple type of vehicle, I will make incorrect code, or I'll expect it to have errors in my code. For example, if you talk about one type, means you can do a final, you can do a string, vehicle equal to car. If it was about multiple vehicles, I would not have designed my, or I would not have coded like this. I would have coded like this. I would kept it as a enum. And let's say I can add car, I can add bike, whatever that I want to add here, I can keep on adding it. Okay. So this is why this is important. If I didn't have this information, I probably would have implemented like this. But later, if I get to know it can also support bike, I cannot change it. Agree? If later the requirement comes that you can also support bike and you can also support truck, I cannot go and change this code because my implementation was done in a way that my vehicle was always expected to be a string. Now I cannot change it because I made it final. So if I know this information beforehand, I would have made an enum value. So let's say after car and bike, you ask me to have truck as well. I can just add one more value to the car and bike. My code is extensible enough. So this is just one example why having a requirement gathering is the first step and why it is important. Okay. Number one. Number two, all of this we'll see when we'll go to the code part and case studies, by the way. Number two is laying down the use cases. It's very important for you to lay down the use case of every stakeholder in the system. Okay. Every stakeholder, which we also call as actor, every stakeholder, which we call as actor, will have their use case, will have their use case in the system. Okay. So based upon their use case, we need to understand and we need to write down what is their specific use case. Let's take a simple example to understand that. If I talk about online banking, or let's say net banking in general, in online banking or net banking, what do you think are the stakeholders or actors in your system? Come on, guys, quickly in the chat. When I say online banking or net banking, what do you think are actually the stakeholders in your system? Who all are who all are actors in that entire system? Customer is one. What else? Come on, guys, think through it. Bankers. Bankers can be considered as another. What else? Anybody else? Customer care rep. I mean, technically, they'll become part of bankers only, right? What else? Banks is a large term. Let's understand this. First thing, on a broad level, there is a customer, there are bank employees, and bank employees you can divide into admin versus not admin. I'm not going much deeper into that. Apart from that, there is external systems. Okay. These are the major, or these are overall the stakeholders that we have. When we talk about customer, what is the use case of a customer? The use case of a customer is they can check the balance. Of course, they can do the transactions. That's why they are customers. What else? They can use features in the app, whatever that features is there. Yeah, transaction means withdraw deposit, whatever they're allowed to do. UPI, NEFT, etc. etc. As a customer, they're entitled to do that. Bank employees, since I divide into admin versus non-admin, this is what I'm referring to non-admin, means they can help resolve transactions related issues. Okay, whatever the transaction related issues in the account, in the customer account. When we talk about admin, admin can lock or unlock a particular account. Only few employees in the bank would have the access to lock or unlock the account. Those we call it admin privileges. This part clear? Not all the employees would have the access. Only a few specific people would have the access to that. All agree? Cool. Then we talk about external systems. So what are these external systems? These are like approvals or third-party integrators. Third-party systems. This is what we call as the external systems. Okay. Overall, these are going to be all the stakeholders with their specific responsibilities or use cases in my online banking. Everybody clear with this? Okay. That was number 2. Now moving on to number 3. Number 3 is UML diagrams. Yes, they are called actors. All the stakeholders are called actors. Now, number 3 is called UML diagrams. So we'll talk about what are the UML diagrams, what are its purposes, so on and so forth. Okay. Before that, first thing, when we say UML, what is the full form of UML? What is the full form of UML? Come on, guys, quickly in the chat. Anybody? Not markup language, but closed. It is unified modeling language. Okay. So this word itself is very important or very clear to understand what exactly is doing. U means unified, means you are combining. Modeling means it's you model all the languages or you model all the requirements into design. What is the purpose of it? The purpose of a UML diagram is converting requirements into diagrams. Okay. It is not related to a particular language. It's not related to a particular schema. It's a unified model. Okay. Unified model means whatever requirements are given, irrespective of how you implement it, doesn't matter which code you're using, doesn't matter which design pattern you're using, doesn't matter which language or tech stack you're using, they will always be same. So if you're given a requirement, UML diagrams denote how should it be converted into diagrams. And then you can decide upon the tech stack, language, framework, whatever you want to use. But this is something which will remain common across all the projects. This part clear to all? Unified modeling language means these are the diagrams, which diagrams are converted from the requirement. So you have a requirement. How do you convert those requirement into diagram? That is what you call as UML. This part clear to all? Okay. Now, UML diagrams are categorized into 3 categories. What are the 3 categories? Number 1, structural diagrams. Number 2, behavioral diagrams. Now I'm talking about category. I'll go to the specific one in these categories. Number 3, interaction diagram. Okay. These are the 3 categories that we have. Okay. And inside these 3 categories, we have multiple subcategories also. Total, there would be around 23, 24. But again, you don't need to know all these 23, 24. 4 ones are important, which we'll focus upon as well. Okay. As part of your project, as part of depending upon which role that you have, if you're senior, if you're a lead, you will be the one responsible for creating these diagrams. Some of these diagrams like class diagram, activity diagram, sequence diagram, use case diagram, you will be coding or you will be designing those diagrams. Okay, we'll talk about it. If I talk about the categories, there are 3 major categories: structural diagram, behavioral diagram, interaction diagram. The name itself tells what they are actually doing. Structural diagram means they tell you the structure. Behavior means they tell you the behavior. Interaction means they tell you the interaction. That's it. Okay. So in terms of structural diagrams, what do we have? We have a class diagram. We have a component diagram. We have an object diagram. We have a deployment diagram. We have a package diagram. And we have a composite diagram. Composite structure, I think it is called composite structure diagram as part of structures. Then as part of behavior diagrams, we have activity diagram, we have state machine diagram, and we have use case diagram. Okay. And finally, in our interaction diagram, we have communication diagram, we have timing diagram, and we have sequence diagram. This is what we have. Now, the question becomes, do we need to know all about the type of diagrams? No. The important ones, I'll just mark it as important. Class diagram is important. Activity diagram is important. Sequence diagram is important. Use case diagram we pretty much have covered already. That is also important. Okay. Overall, these four diagrams are important. You want you want to know about all the diagrams? Go ahead, learn about it. But at the end of the day, you'll be working on these four diagrams only: class diagram, use case diagram, activity diagram, and sequence diagram. And that is something which will capture the entire flow of the project that you're going to build. Okay. I am going to first show you the images one by one. I'll start with all UML diagrams first. So let me quickly pop up my screen. Let me walk you through how all UML diagrams looks like first. Okay, let me quickly share my screen. Let me know once you guys can see it. There you go. So this is what we have. We have behavioral, we have structural, and then we have interactional as well. Okay. So in terms of, let me take this point, let me explain it here. Structural class diagram is the one which we have important. We have component, object, component structure, deployment package. In behavior diagram, we have the activity important. I'll just highlight this. We have this use case important. And in interaction diagram, we have the sequence diagram important. These four are ones that are useful for you. This part clear to all UML diagrams. Come on guys, be quick. This part clear to all? Okay. If this part is clear, now let me take you to other diagram. I'll come to this. Yes, I'll share this image. I'll come here. Okay. So all UML diagrams, this is what we just covered. I'll mark it as done. After that, I want to show you the class diagram. How does the class diagram look like? We'll learn how to make class diagram too. Activity diagram, use case diagram, and finally a sequence diagram. All the four important ones, I'll give you a specific example to understand that. Okay. We'll spend our time here to go one by one in sequence, going through the class diagram. Later, we'll go to draw.io. We'll start making class diagrams as well, by the way. Then we'll talk about activity diagram, use case diagram, and sequence diagram, all in sequence. So let's start with number one, class diagram. So let me quickly get a screen for you for class diagram. Okay. I'm going to share my screen. Let me know once you guys can see it. Come on guys, be quick. Can you guys see my screen? Just let me know. Everybody can see a diagram, class diagrams. Okay. Now understand what does this class diagram is and what does class diagram technically includes. So I'll go step by step to explain all that. All of this that you are seeing, irrespective of the color, yeah, I'll talk about it. All of this that you are seeing, irrespective of the colors, all of them are classes. So customer is a class, order is a class, order detail is a class, item is a class, credit is a class, check is a class, cash is a class, payment is a class. How we typically design a class diagram is we divide into majorly three parts. The first part is called the name of the class. For example, order is the name of the class. Now, from the basics of class, you would know about one thing. What is a class? A class is combination of data members and member functions. All agree? A class is a combination of data members and member function, or a class is a combination of data and behavior. That's the most basic definition you would have learned for the very first time. All agree with this? Come on, guys, be quick. There are some data members based upon the data type, and then there are some member functions. So if you look at this, the first part that we allocate to the data members. For example, I have a date, which is of the type date. I have a status, which is of the type string. So first we start with the name, then we start with the data members. Okay. Then finally we talk about member functions. Basically the functions which are defined in a class. So let's say calculate subtotal, calculate tax, calculate total weight. All of these are member functions. So in a class, we have the name of the class, we have the data members, and we have the member functions. This is how a class diagram is created. This part clear to all? Easy, nothing complicated. We'll make a design also, don't worry about it. But just to tell it, it's pretty simple, easy. Three things: name of the class, data members, member functions. Also, one more thing. A class can have a lot of data members, a class can have a lot of functions. Do we need to show all of them? The answer is no. Typically, when we talk about member functions, we don't type constructors. We don't talk about getters and setters, right? So if you look at this, the purpose of a class diagram, it should highlight the functionality of it. So I will not be writing constructor here. I will not be writing set order, get order, all of those things, or set date or get date, all of those things. It's commonly understood, it will be there. Getters and setters will be there. You will be getting and setting those values for sure, right? But you don't need to show that in the class diagram. A class diagram should focus only on the functionality aspects for the member functions. Okay. Yeah, that's what I'm saying. Irrespective it is private or public, that doesn't matter. We don't need to tell private or public. Okay. What is important is, but if someone is looking at your class diagram, they should know what that class is functionally doing it. Okay. So if I look at this class diagram, let's say order, I can understand it. Okay. It's calculating the total, it's calculating tax, it's calculating total weight, etc. etc. That's something I can look at the class diagram. I can make a sense out of it. People don't need to go through the code. See, understand, diagrams are only for the overview part. If somebody will review it, somebody will get to know, they'll understand, okay, this is what the code will be doing. And based upon this, you will be actually writing the code. So this is the first part. It's not like you write the code and then you create the diagrams. You first create the diagrams, then you write down the code. Okay. So if somebody will review it, they will know, okay, what to expect in the code. Now, member functions are only supposed to write those functions which are denoting the actual functionality of a class. There can be 1,000 functions. You don't need to put all 1,000 functions. Let's say there are 5 functions which are denoting the functionality of the class. That's what you need to write here. Okay. Same goes for data members. There can be multiple data members, hundreds of data members. You don't need to mention all the 100 of them. You need to mention about those data members which are important for you. For example, order date is important, order status is important. That's why. Okay. All right. Let me clear this. Let me go back to Sublime Text. There we go. Okay. So in general, a class diagram, you start with the class name. Then you go to the data members. How do we write data members? Name of the data members and return type. Okay. Data members again, useful data members. And finally, we have member functions. So usually we don't write constructors, getters, or setters. We don't write that usually. Important functions defining the functionality of the class. That is what we stick to usually. All the important functions will define the functionality of the class. Okay. All right, guys. That was the example for class diagram. Everybody clear with class diagram? Quickly in the chat. Everybody crystal clear with class diagram. Okay. Now let's move on to the next diagram, which is activity diagram. So let me pull up that screen for activity diagram. Let's go one by one. 299 could explain again. 299, what I'm talking about is in member function, we don't write down all the functions. We only write down all those functions which are defining the functionality of the class. Okay, that's it. Let's go to the next diagram, which is our activity diagram. Okay. So what is this activity diagram technically denoting us? The activity diagram just denotes how the flow will actually work in a particular design. Okay, what are going to be the activities? So if you look at this as part of this activity diagram that we have here, this is denoting the process order. So what happens? You get a requested order. First you receive the order. Now there are two cases. Either the order can be accepted or the order can be rejected. If it is accepted, you fill the order, then you create an invoice. So you can send invoice, then you can ship the order, then you can accept the payment, and then finally you'll close the order. If it is rejected, then you will directly close the order. So this is what we denote as the activity diagram. What is happening at each instance of a particular design or each instance of a particular system, what all activities are being triggered, that is what we call as activity diagram. Okay, let me close this. Nothing much to discuss here in terms of activity diagram. So I'll come back here, put it here. That was your activity diagram. I'll take the next, which is use case diagram. Let me get to the screen for a use case diagram. There you go. We'll talk about the use case. Use case means I have to highlight all the stakeholders in the system. That's what we'll be doing. Okay. Now, coming to the use case diagram, what do I need to mention about? Only thing I need to mention about is what are the important actors in the system and what systems will be taken care for. Active diagram, flow diagrams are same, right? No. Flow diagrams, okay. Flow diagrams is not technically a diagram. Flow diagram is something that you define. You can define the sequence flow, you cannot define the sequence flow. Whatever you call by the definition of flow diagram, it's up to you. There's nothing called flow diagram. Sequence diagram is a name of a diagram. Flow diagram is no diagram as such. Okay. Flow diagram, you can design some bare component for it for your system, and then you can mention how the data is flowing or so on and so forth. Activity diagram is the actual diagram. So activity diagram denotes what part of the system is interacting with the other part and how the activity is supposed to follow, or basically what are the activities in the system. Okay. I'll come back to activity diagram a bit later. Let's talk about the use case diagram because we already discussed the use case diagram. What is use case diagram? As we have taken an example of the online banking or the net banking, you remember, we talk about who are the stakeholders in my system, right? Which we call as actors, and what is the use case of that actors. Use case means responsibility of that actors. Okay. Now this use case diagram that you are seeing right now in front of your screen, that is for an online shopping system. Online shopping system. So think of any e-commerce system that you can think of. Let's take Amazon, Walmart, whatever you want to take, and try to understand what are the component, what are the actors here. So if you look at the actors, I'll go step by step. If you look at the actors can be a customer. So if I look at it, there you go. My actor is a customer. Then I have identity provider, I have a credit payment service, I have, let's say, PayPal, and I have authentication. These are my actors in the system. Now, my web customer can either be a registered customer or it can be a new customer. So we divide into two categories. If it is a registered customer, they can view the items. Let me take this guy here. They can view the items and they can purchase the items. Okay. And obviously they can check out from there. If it is a new customer, they need to first register it. Only then they can access all of those things. Okay. If they register it, they have to go through the authentication, service authentication. Even the registered user have to go to the authentication via the identity provider. Then when you check out or when you actually make the payment, that is when you have an option to include a credit payment service, because this credit payment service sector that was never included before till the time of payment. When is the time of payment? That is when this credit payment service will be included as an actor. Okay. PayPal, Visa, whatever that you have, that is when it will come here. So this is the example of use case diagram. Simply put, use case diagram just denotes what are the different actors in the system and what is the use case of all the actors. This part clear to all? Come on guys, quick in the chat. This part clear to all? Okay. If this part is clear, please explain checkout, identity provider, why view items to identity provider. It's up to you how detailed you want to make it. It's not like you have to make this all detailed all the way, just giving an idea. Okay. One moment. What are terms like include? You can ignore it, not relevant for our use case. Okay. Let me go question step by step so I don't miss anything. Checkout identity provider. Okay. So when you're going to actually check out, well, technically identity provider will be used while you're doing the viewing items. So when you're doing viewing the items or when you're checking out, it will check whether you have the appropriate access or not. Okay. So once you log in, you will be able to log in or you will be able to view item or check out or even make purchase once you have the appropriate credentials. That's what the identity provider is doing. Okay. Next, why view items to identity provider? Already answered. In order to view items as well, you need to be logged in as well. That's why the identity provider. Okay. All right. Any more doubts? Any more questions which is not clear? Overall purpose of use case diagram, list down all the actors, list down the use cases of all the actors. That's it. Nothing else. Cool. Let's go back to Sublime Text. This is what we just discussed. Use case diagram. Now, before I go to the sequence diagram, somebody asked a question for the activity diagram. So I'll quickly go back there. Let me know what is the question, then we can close this part. This is activity diagram. What was the question here? Let me know. Activity diagram is just denoting the sequence or the activities in which how the activity or how the entire system is performing. Okay. A simple example I explained for the process order. So the purpose of activity diagram is list down all the activities which is going to happen as part of a system. So when I process an order, this is what I'm doing here. You can call it workflow, you can call it something else. That is what it is. In a system, what are the components, how are they expected to behave, how is the end-to-end flow works? That is what you call is an activity diagram. The reason we call the word activity is because denoting all the sequences. That's why we call it activity diagram. Okay. This was the activity diagram. Let me know what was the question or if there is any specific question. If not, then we can move on to the last diagram, which is sequence diagram. Come on, guys, quickly in the chat. Can you repeat the use case diagram? We define the actors first, then add their use case interactions accordingly. Yes, we define the actors first and then their use cases and then the interaction. That is correct. That is correct. Okay. In general, a use case diagram is just used to denote the actors, how they're interacting with each other and their responsibilities. Okay. Cool. All right, guys, step by step. I cannot share multiple screens at once, so I need to go step by step. Any doubt in the activity diagram? Everybody clear with the activity diagram? Okay. If everybody is clear, then I can close the screen. I'll go back to the other monitor. There we are. Let me close the screen. Let me pull up the activity use case diagram again. Okay, now let's go for it. This checkout to identity provider, as I said, not everybody would have to do the access to checkout, everybody would have to access the view. So what you need to do is you need to check whether the customer has the access to view the items or has access to check out the items. Okay, understand this. If you are not, I'm just giving a simple example. Let's say if you're not logged into an e-commerce website, let's take any e-commerce for that example. Can you still view the items? If you are not logged in an e-commerce website, can you still view the items? Yes or no? Of course you can. If you have not logged in, of course you can. But if you're not logged in, can you check out the items? You cannot check out the items, you cannot place an order, you cannot do that. That is why we need to have this identity provider here. So if a customer is checking out, whether it's a valid customer or not, whether they have actually signed it or not, all of those things. So that's why you see checkout is matching to the authentication, checkout is matching to the identity provider. That's what. Okay. All right. Now let's go back to our Sublime Text. So we did talk about class diagram, we did talk about activity diagram, we talked about use case diagram. Now, final diagram that we're going to talk about is the sequence diagram. The name itself says what this diagram is going to be about. This is all going to be about in the sequence, how does a particular design follows. So let me open the sequence diagram, then we'll go through it. Okay. I'm going to share this sequence diagram. I'm going to give you 10 seconds. Have a look at this. Then we'll discuss about what this is. I don't want to tell you what this is. Have a 10 seconds, look at it, then we'll discuss. All right, guys. I've given 10 seconds. Let's discuss this. What do we usually do in a sequence diagram? What exactly is this sequence diagram? This is sequence diagram for an online bookshop. Okay. So what we usually do is we define like a customer, we define like whatever stakeholders or whatever different components of the system, depend upon how how detailed you want your sequence diagram to be, how many stakeholders are actually involved. For example, there are many stakeholders. If you want to include as part of sequence, you can do it. Okay. There is no hard and fast rule how you can make a sequence diagram or any diagram for that matter. For a class diagram, there are standards we follow. Same goes for the use case diagram. But for sequence diagram, depends on how much sequence or how much details you want to show it. Okay. So coming to this, we have a web customer, we have online bookshop. We can keep it with just these two. I can create a new called payment, I can new called something like that. I can more add the more details. So it's not like there's a hard and fast rule that I have to follow. So for a very simple one, first a customer will search the inventory and will get the result from the bookshop. Then they can view the book description, that is an option. They can add to the shopping cart, that is an option. And then they can do the checkout. Basically, it lists down all the functionalities that you can do. The purpose of a sequence diagram is it tells you the sequences in which a particular task, a process, or an event is supposed to happen. For example, search inventory will only happen from customer to workshop. A customer can make a query to search the inventory. The result which will be generated, that can only be generated from the workshop to the customer. That's why I look at the arrow signs. Okay. Similarly, a customer can view a book description that will go to the bookshop. A customer can add it to the shopping cart and customer can do the checkout. All of this. Basically, whatever sequence of process, task or events, those are captured as part of the sequence diagram. Everybody crystal clear with sequence diagram? Any question, anything which is not clear, let me know. Okay, all good. Let's go back to our Sublime text then. These are the four major diagrams that we have. Class, refer for checkout means. One moment. Refer for checkout means payment. That's it. Okay. Sequence and activity diagram. Ref means. Ref means, what do you mean by ref? A reference. You can just ignore it. So this is optional. This is reference. That's it. Okay. You don't need to add this. You can add the sequence diagram in the way you want. You don't need to put this if optional and all of this. As I said, there is no hard and fast rule. There is no hard and fast rule. You can add the complexity of the details that you want to there. Okay. Sequence diagram is more or less similar. See, activity diagram is completing at every part, right? Sequence diagram is just noting the sequence of it. So not exactly same. Activity means what will happen at each use case. For example, we talked about when the process gets cancelled, when the process does not get cancelled. That is what activity diagram was. Covering all the scenarios, what will be the activity, what will the behavior of my system. Sequence means these are the different components. What sequence does my process goes or the event goes or the task goes. That's it. Okay. All right, guys, quick check. This is the four diagram that we need: class, activity, use case, and sequence. We have taken the example of these four. Later on, we'll be writing or drawing the class diagram on draw.io as well. Okay. What have we covered so far? We have covered the requirement gathering. We have covered the link down use cases. We have covered the class diagram, activity diagram, use case diagram, sequence diagram. We have covered this much. Okay. Now we'll move to number 4, which is understanding object-oriented programming versus object-oriented design. The first part that we have here is classes and objects. So let's clarify this part first. What are the classes? What are the objects? Then we'll move to it. So first thing, I'll start with classes. What are the classes exactly? Any one of you knows when was class invented? Don't Google it, guys. I don't want the Googled answer. Any one of you knows when was class invented? Come on, guys. Nobody? Could you please repeat the difference between activity and sequence? As I said, activity diagram is denoting all the scenarios in which how a particular design is supposed to behave. Okay. So example of the activity diagram that I have shown was in the case of process order. So what happens in the case of a order got accepted or order got rejected, all of that is taken care. Sequence diagram, on the other hand, is only talking about the sequence of the events or sequence of the task or the processes. We are not covering all the scenarios in sequence diagram. In sequence diagram, we talked about which are the major components, let's say a request, a response, or a client or a server, and if there is any other external party which is involved here, and how does the sequence flows through it. We don't talk about all positive or negative scenarios there. In activity diagram, we cover all the kind of positive and negative scenarios. Okay. All right, guys. Coming back to my question, can anyone tell me when was classes invented? Okay. With the inception of programming language like of C. Does C have classes? Are there classes in C language? Okay, cool. You'll be surprised to know before even we move to classes, functions, all of functions is very old. I won't say functions, classes and interfaces and all of these things. There were used to be assembly languages. Okay, COBOL, Pascal. I don't know if anybody has worked on it or at least know about it. There used to be those languages, COBOL and Pascal, assembly languages. People used to write code in that. There's still people who write code in assembly languages, especially who are working in specific finance sector, specifically in finance sector. They still write the code. Okay. Anyways, coming back to it, there was programming even before class was invented. So it's not like class was always a concept there. There was program written, there were program written in at a huge scale at a high big companies even before class was a concept which was known to programmers. So before class was invented, there was something called a structure. Okay, let's take an example. Struct employee. You have employee ID. Struct employee. You have employee ID, and you have a string name. Okay. Now, what is the definition of a class? The definition of a class is a combination of data members and member functions. Okay. In the case of struct or structure, whatever you call, we don't have the member functions. We only have the data members. Okay. And then we used to have functions which are separately. We have functions. It's not like we do not have functions. We cannot change the value. We have functions, but those functions are not part of the structure. A structure just contains the data members of functions which are created separately that uses the values or that uses the data members in a structure to manipulate their behavior. This part clear to all? Come on, guys, quickly in the chat. I'm talking about how the programming has evolved over years. You need to know these basics. When there was no class, is it that we cannot code? Is it that we cannot do the job as a programmer? No, it's not like that. Did class provide me a lot of functionality? Yes, because we clubbed the data and the member function together, so it becomes very easier for me to have multiple things. I can have the private, public, protected type. Based upon that, I can choose which data to manipulate, which data not to manipulate, which method to give the access to manipulate, which method not to give the access to manipulate. A lot of things become easy for me. But that does not mean if there was no class, we are not writing the code. It's nothing like that. Okay. What we were doing before was to keep all the data, we used to keep something called structure, which can contain different data type. Okay. So these were the data members, and then we used to have functions separately. So I'll pass this structure, and in that structure, I will use manipulate this value or this value, whatever I have to do. And that's how we were doing our job. When they were separate in nature, let me put it that way. They were separate in nature. After the class was invented. Okay. The first language which has actually the concept of class formalized and documented was C++. That is why it was initially called C with classes. Nobody called it C++. People used to call it C with classes. Later it got termed as C++. It just denote incrementation. Okay. The person who wrote that was Bjarne Stroustrup. Okay. He was the guy who wrote the language C++ in the year 1979. So that was the first time publicly when the concept of class became available to programmers, which is how many? 20, 20, 45, 46 years from ago. So approximately 46 years ago, that's when the concept of class was known to programmers. Okay. So take an example of class. How does the class look like? Let's say class employee. I can have a combination of data member, which is my property. Let's say employee ID, string name, and member functions. So member functions include my behavior. What kind of behavior? Let's say get salary and get bonus. Those things. So what is a class technically? A class is a combination of data members plus member functions. Okay. This is property plus behavior. If you take an example of employee, even I can create an object out of it, new employee, and then I can access it using an object. This is how we work with classes. So we have a class, we can create an object out of it, and using that object, I can access the data members and member functions. Everybody crystal clear with this? Come on, guys, be quick. Everybody crystal clear with this? Okay. Quick question. Let's see who can answer it. Can I directly access a data member or member function without creating an object with just a class? Can I directly access a data member or member function without creating an object with just a class? Correct. Only one condition. If that data member or that member function is static in nature, then you can directly access by class. In that case, you will not access by objects. There's no point in accessing by object because it will be shared across all the objects. So in that case, you'll access by class. If it is non-static, which is by default, if it is non-static, in that case, you have to access by a particular object. All good with so far? Let me know. Okay, cool. If this part is clear, let's move on to the next topic, which is object-oriented programming versus object-oriented design. Object-oriented programming versus object-oriented design. Let's try to understand the difference between object-oriented programming and object-oriented design. So write the full form first. This is object-oriented programming, and this is object-oriented design. Now coming to first part. What is object-oriented programming? Quickly in the chat, guys. Come on, guys, quickly in the chat. You guys have been learning it so far. What is object-oriented programming? What's the definition of object-oriented programming? Okay. Come on, guys. This should not take this much of time. Okay. Cool, guys. Anyways, so what is object-oriented programming? Understand. There are four pillars. So what you are talking about is we are talking about the pillars. But what is object-oriented programming? Object-oriented programming means we program based upon the objects following some pillars. Those pillars are called inheritance, polymorphism, abstraction, and encapsulation. Okay. So inheritance, polymorphism, encapsulation, and abstraction. These are the four pillars that we have. Okay. So coding up an application slash program using the object-oriented features. That is what we call as object-oriented programming. Okay. What is object-oriented design? Let's try to understand that. The word object-oriented design is we model a real-world problem using object-oriented design techniques. We try to model a real-world problem using object-oriented design techniques, which includes solid, dry, keep it simple and short, etc., etc. Okay. Now the question becomes, can I use object-oriented programming without object-oriented design? And second question becomes, can I use object-oriented design without using object-oriented programming? Let me know the answer for both of them based upon your understanding. Can I do first? Yes or no? Can I do second? Yes or no? So just give me one answer, which is denoting either it is YY or it is YN or NY or NN, whatever answer it is. Question is clear? Okay. Quickly in the chat, guys. Be quick. All right. Majority of you have given the answer. The correct answer is, can I use object-oriented programming without object-oriented design? Yes. Object-oriented programming is not based upon the object-oriented design. Can I use the object-oriented design without object-oriented programming? The answer is no, you cannot. The entire object-oriented design is you're modeling a real-world problem using object-oriented techniques. So if those technique itself does not exist, what can be done while violating object-oriented design principles? But you cannot do the other way around. Okay. Example, driving is object-oriented programming. Overtaking is object-oriented design. Now understand thing. You can drive without overtaking, but you cannot overtake without driving. This example clear to all? You can drive without doing overtake, but you cannot overtake without knowing how to drive. Okay, that is the difference between object-oriented programming versus object-oriented design. Now moving to the next part, which is we have been waiting for, NVT and others. But before that, let's have a very clear understanding of classes, and objects. That's the next part. We all know this, so I want to go quickly through this session. We don't want to spend too much time into it. So you guys can quickly tell me in the chat. We can go it from there. In one line, without any Google definition, without any ChatGPT definition, in one line, tell me what is a class and what is an object. As software engineers, this is the first topic that you would have understood. In a very simple word, in a very simple line, very simple plain English, tell me what is a class, what is an object in one single line. Quickly in the chat. Come on guys, be quick. 10 seconds for this one, not more than that. One single line. What is a class? What is an object? Quickly. All right, guys, this should not take this much of time. Be quick. Let's see what we have. Template for similar type of element, representation data function, a class, blueprint of a class, instance of a class. Blueprint of a class. Is object a blueprint of a class? Data plus method, use of class as a purpose, way to access a class is defined, class is a blueprint, object instantiation, real world entities which have data members and member functions, combination properties. Okay. Too many definition, guys. Let's make it very simple and clear. There's no point of using highly used adjectives. That's not the answer. As I said, simple plain English, just let me know what it means. Class. Does class technically exist? Does class technically exist? Or is it just a blueprint? Correct. It is just a template. It's just a blueprint. Blueprint or template of objects. That's it. Class is not something which exists. Class is just a blueprint. It is not a real world entity. When does it become real world? It becomes real world once you have the objects. Objects are the instance of a class. Okay. So when you instantiate it, that is when you create the objects. Object is a real world entity. Object is a real world entity. Okay. Let's talk about examples one by one. If I have blueprint of a compartment of a train, just the blueprint. So in that blueprint, I know how the compartment should look like. I know the size, I know the dimension, but it's not a real world entity. It's just a blueprint that I've created. That is what your class is. Once you convert into an actual compartment, once all the development has been done, all the things have been fixed, that is when you call the actual compartment of a train, not a blueprint anymore. That is what you call as object. This part clear to all? Quickly in the chat. This part clear to all? Okay. Now let's understand this with a code. I move to the code part. Let's understand this with a code. I create a class employee. In that class employee, I'm creating an integer array. Can I have an array in a class? Yes or no? Can I have an array in a class? Yes or no? Of course I can have. What's the problem? Now tell me the answer of this question. What is the size of this code? If I run this code, only this code, what is the size or what is the memory it will take? Quickly in the chat, guys. Is the code that I've highlighted on the screen, if I run it, what will be the memory occupied in bytes, in bytes, in the memory? Come on, guys, be quick. I got only one answer. What about other people? Quickly in the chat. Nobody else? This is a very popular interview question, by the way. Okay. Anybody else? You tell me how to calculate. Okay. This is a very popular question in the interview. This is what we usually ask it to first year students in graduation. The answer is zero here. What did I just explain? Class is just a blueprint. Class is not a real world entity, it's just a blueprint. Until and unless I instantiate a class, that is when it will happen in the real world. Have I created any object yet? Have I created any object yet? No, I have not created any object. I just written the code of a class. The moment I do this, employee E1 equal to new employee. The moment I have done this, now you can say the size of E1 in bytes will be what? It will be 404 bytes. Why 404 bytes? This is a 400 for the array and there's another 4. So 404 bytes. This part clear to all? This part clear to all? Okay. So now coming back to the class. Class is a combination of data members plus the member functions that we already know. When we say data members, what does that mean? It's the information, or we call as attributes. This include data variables, constants, and enums. Okay, those are data members. When we talk about member functions, that means behavior or the properties, which we call as functions. Okay. To understand that in real world, let's talk about real world example. Real world scenario. If I talk a class, let's say a car. If I take a class of a car, what will be the attributes and what will be the behavior or properties? Let's talk about it. Attributes can be a car can have what? A car can have wheels, a car can have a color, a car can have a engine. All of these are attributes, data members. What about the behavior or the properties? Properties means what happens if I accelerate? Accelerate. What happens if I drive? What happens if I stop? All of these are properties. This is a real world example to understand a class or to understand data members versus member functions. And now if I talk about objects, let's say. So my objects can be, I can create car C1, different instances. So new car, I can instantiate different kind of classes. I can have a Tesla, I can have a Beamer, or I can have a Merc, whatever that is. This part clear to all? Real world scenario to understand class. Class is a combination of data members and member function. Data members denotes the attributes. They're not denoting the behavior. They're just denoting the attributes. Functions are denoting the behaviors. So these are my properties, or technically these are my behaviors. These are my attributes. Okay, cool. Let's take one more example before I go to next. Let's take the example of class human. In that class human, I would have attributes and I would have behavior. So attributes can be in a human, it can be a height, let's say, it can be a weight or anything else that you want to insert this. Behavior can be human can talk, human can walk, eat, whatever that is. Okay. All of these are behaviors here. Everybody crystal clear with this. Come on, guys, be quick in the chat. Okay. If everybody is crystal clear, now I'd like to cover one last thing as part of today's session. Let's see where we are in the syllabus before I move to the last thing. So we have covered this part, NVT technique, case study using NVT technique, and then finally creating a class diagram on raw.io. This is what I want to cover, and this will easily consume more than 20 minutes. That's what we have as of now. So we'll talk about what is NVT technique. Then we'll take a case study to understand that, implement that NVT technique, and then we'll create the diagram on raw.io for the class diagram. Okay. But before that, I'll quickly revise what you have done till so far. We talked about the agenda for LLD course. This is going to be the agenda. This is roughly going to be the number of classes. That's what we have in the agenda. Then we talked about high-level design versus low-level design. We talked about what does high-level design course actually introduce? What is the scope of high-level design? What is the scope of low-level design? I mentioned some of the resources for low-level design, few resources for the high-level design as well. Then we talked about requirement gathering, why it is important to have a requirement gathering in terms of program. We discussed that. We talked about laying down the use case, what are the different stakeholders, what's the purpose of stakeholders, so on and so forth. We talked about EML diagrams, their types and purposes. Overall, we can divide into 3 categories. They have further subcategories. The important ones we have gone through. We have gone through the class diagram, activity diagram, use case diagram, and sequence diagram. Finally, we talked about class diagram in detail. These are the useful, how do we create it, etc., etc. We start with class name, data members, member function. And that's something we're going to draw very soon in terms of draw.io. We talked about class in detail, what does class contains, what happens when class was not there, what happens when class was there, so on and so forth. Then we talked about object-oriented programming versus object-oriented design. We talked about class and objects. In terms of real-world scenarios, class is not a real-world entity, object is a real-world entity. We talked about the code, we talked about everything here, along with some real-life world example. Now I move to the last topic. Let's talk about it. This is NVT technique or trick. Which is a case study diagram using case study technique. Okay. NVT technique or case study, which is a diagram using the case study technique. Let's talk about it. First of all, what is that NVT technique that we are referring about here? That NVT means noun, verb, technique. NVT means noun, verb, technique. What does the technique tells you? Technique is wherever there is a noun, it's denoting a class. Wherever there is a verb, it's denoting a behavior. Okay, behavior of functions. So let's verify this with an example. We're going to do one case study, and then we'll talk about how do we make a nouns and how do we make a verbs out of it, and then we'll try to make a class diagram out of it on draw.io. So NVT technique says whenever you're given any kind of problem statement, any kind of requirements, any kind of case study, if you have to understand how to make a class diagram out of it, a very simple trick is highlight the nouns and highlight the verbs in that. The nouns will correspond to the classes, the verbs will corresponding to the functions, okay, or behavior. So start with a case study. I'm keeping that case study for, let's say, Udemy classes case study. Let's verify with this. So number one, a user goes to the website and selects the batch slots for the course. He or she wants. Okay. Number two. Second, they add them to the cart. Number three, they check out and make the payment. And number four, they get a confirmation of courses being enrolled. Okay, that's it. Now, this is the case study which is given to you. Now, tell me just one thing. Out of these four statements, what are the noun and what are the verbs? Quickly mention in the chat. Give a proper heading. These are the nouns and these are the verbs. Let me know. This is the case study I'm giving in the chat as well. Segregate the nouns and segregate the verbs. What will that do? Noun will become the classes. So what do you think should be the classes as part of this case study? One moment. What should be the classes as part of this case study? Write it down. What should be the behavior as part of this? Write it down. Okay. Do that in the chat. I'll not give more than 1 minute for this. 1 minute should be sufficient enough. You can message to everyone. It's not like you have to directly message. Take 1 minute, write down the noun, write down the verbs. Case study is already given in the chat. Your time starts now. Already has enough time. So what are the noun and what are the verbs? Let's talk about it. What can be turned as part of the classes? What can be turned as part of the behaviors? Okay. Number one, writing the noun. User is a noun. Batch is a noun. Courses or codes, whatever that is a noun. What else? Cart is a noun. Payment is a noun. All of these are noun. They can be different classes here. What about the verbs? Let me highlight. Noun represents the classes or the objects. Basically, classes will be converted to objects. And verbs represent the behavior or the functions. What behavior do we see? Number one, select the codes. That is one behavior. Number two, add them to cart. That is a behavior. Number three, check out and make payment. That is a behavior. Number four, course is being enrolled. That is behavior. So what do we need to do? Based upon that, we are going to create a class diagram on draw.io. Okay, let's do that. Based upon this information, based upon the noun that we have separated, which will be classes or objects, based upon the verbs which are separated, which will be functions. Now what we need to do is we need to actually create a class diagram. Okay, so let's try to do that. Confirmation of payment. As part of this, we have not written it, but obviously there will be a confirmation of payment. But as part of this, I made the verbs basically what is written till these 4 lines. That's it. Okay. All right. Now let's go to draw.io first. All right, guys, majority of the diagrams that will be denoting and majority some of the times your company might have internal tool, but if you have to practice on how to create diagrams and stuff, this is the website that you will be using. Draw.io or apps.diagrams.net. Okay. Everybody can access this link. Let me know. Just click on this link and let me know if you guys can access it. Everybody can access it. Okay. Once you access this link or once you go to the link, this is the first thing that you will look like. Come on, guys, quickly in the chat. Everybody can access it. Okay. This is the first link that you will look like, which is create new diagram and open existing diagram. So I'll click on create new diagram. In that create new diagram, you'll find multiple things. You'll have a blank diagram, you have a generate feature. So you can describe the diagram, they can generate using generative AI. There's a class diagram, flow chart, organization chart, simulation diagram, entity relation, sequence diagram, all of this. Okay. So if you look at the UML part, they have multiple UML diagrams here associated. Okay. If you want to create UML diagrams, it's very easy. For software, they have specifically kind of diagram, class diagram, etc., etc. Okay, business, they have others, basic, they have others, so on and so forth. So first thing first, I will just name it as today's session, 12th Gen LLD. I just want a class diagram. I don't want anything else. So I will just create a class diagram. It will try to save it somewhere. So let's say I'll save it here. Okay. It is simply create a simple class diagram here. I don't need all of that, so I can delete it. If you want to create a class diagram, you can just import the class diagram for here as well. Okay. There's an option called UML. In that UML, you can import the class diagram wherever you want. Okay. I can simply modify this. I can remove this. I don't want this. I don't want this. I don't want this. I can remove it. What I do want, however, is understanding my use case and then I'll upload it. So first, I will get this guy here. I will list down the requirements. I'll increase this. I'll increase this. I'll list down the requirements here. What are the requirements we talked about? We talked about the requirements like this. Okay, I'll zoom it a bit. This looks good. Now this is my requirement. Focus on this part here. I have my noun, which I need to map to clauses. If I can edit it, this is fine. And if I can edit this, I can try this also. If I can edit this, I can try this also. Okay. So I would have my noun, which is classes and objects. We have 1, 2, 3, 4, 5 classes. And then we can have, why this one is so space? Okay, that's fine. We have different noun, or this is the classes, user, badge, courses, cart, and payment. And these are the verbs that I want. I can take any one of the or two of the classes and we can see how we can create that class diagram. So let's say I want to create it for user. Okay. And I want to create it for, let's say, cart. That should be good. So if I talk about user, what information you can think about user? So information can be name, which will be of type string. Information can be, let's say, age, which will be of type string. And information can be email address, which is again of type string. What can be the member functions? Member functions I can think like a get name or a set name. So can I add one more to it? Let's see. Nope, it's just adding this exactly. So I don't want that. It can be a get name or it can be a set name, something like that. That becomes my class diagram simply. Similarly, if I talk about other things, for example, in case of cart, what thing I would have in my cart? Let's try to understand that. My cart would contain courses, which is going to be an array of courses. So courses will be another class. My cart will contain courses, which will be of the type array of courses. Everyone agrees with this, yes or no? Come on, guys, quickly in the chat. Everyone agrees with this. Okay. What else? I can include more thing in the cart, but I don't want to complicate things. So I'm just deleting all the things which we might not need and just keep only the things which are relevant. So what are relevant? First thing, I would have an add course, which will take what? Which will take course ID as parameter. Let's say it is void. Okay. Copy this, paste it here. I can have something for delete course, and I can have something for, I don't want to delete this. Zoom this a bit. After that, I can have something called, let's say, get cart total, and that can be void too. What is the sum of the cart or what is the total of the cart, so on and so forth, like this. Okay. This is how you create a class diagram. So using the NVT technique, I've just shown you how do you segregate noun versus verb versus. So noun is representing the classes objects and verbs are denoting the behaviors of function. How do you create a class diagram? Simple, name of the class, then you have the data members, then you have the member functions. Name of the class, data members, member functions. Everybody crystal clear how to create a class diagram and the NVT technique? Okay, that's the example we have seen through. And this is the website we'll commonly refer in the case of creating any design diagrams. So I'm putting that here again in the chat. This is important website. You can practice all your diagrams here. You can also generate based upon generative AI if you want to utilize that feature. Okay. Website draw.io. Okay. Some of the HLD diagrams, I won't say very detailed HLD diagram, but some of the HLD diagrams you can create. Some of them, for example, basics like database, lambdas, all of this that you can create. Okay. All right. That's it for today's session, guys. Let's quickly revise what you've done as part of today's session before I wrap this up. This guy is done. This guy is done. This guy is done. So I've covered the four things. One moment. We've covered the four things here. For creating the high-level design, I personally prefer the many websites. There's a website called Airflow or Airfly, something like that. That's something I prefer. Let me check out the link. Okay, what was the website? This is Lucid Chart. That's the website I was referring about. This is Lucid Chart. Okay. You can create from Lucid Chart or you can create from TL Draw also. So let me put it here. You can make draw.io definitely. And apart from draw.io, there is Lucid Chart that can help you make design diagrams. HLD1. All right, guys, coming back to this, we have covered these four parts and then we'll continue from the next class. We have to cover a lot in terms of our LLD course. I've already walked through the agenda. We talked about the definition of or the scope of high level design versus low level design, what is expected. We talked about the resources for high level design, low level design. We talked about requirement gathering. After requirement gathering, we talked about laying down the use cases. What are the UML diagrams or different category of UML diagrams, the important UML diagrams. We have highlighted that. We have gone through that images. We talked about to create a class diagram, and finally we have created in draw.io as well. We talked about classes, what happens when it was not created, what happens if after it is created. We talked about object-oriented programming versus object and design in detail. We talked about class and objects along with real-world examples. Finally, we implemented the NVT technique to finally create a draw.io using a case study for Udemy. Okay. How to practice on HLD? You can take any business product that you want to make, any product that you can think that you use, and try to make a high-level design for that. Okay. You can take out the questions which are available on internet, and then you can try to create the design for that. Okay. A good thing is think of all the product that you're using in daily life, try to create a HLD out of it. I'm pretty sure there will be something that you'll find on the internet related to that. Try to compare the kind of high level design that you have come up, whether it resonates with other people or not, or other common solutions or not. Okay. All right, guys. Any doubt that I have told in today's session? Any doubt that I have told in today's session? Everything clear? Cool. If everything is clear, let's wrap up the session here for today. We'll connect in the next class. We'll continue there. We'll explain more on OP pillars while coding. I think these are very basics, but yes, once we go to the case studies, we can discuss on that. Okay. Abstraction, encapsulation, these are like very basic things, but we can cover on that once we go to the case studies. Okay. All right, guys, let's wrap up the session here for today. Let's catch up in the next session. We'll continue our LLD design course from there. Thanks for joining in. Have a good one.